Our next problem is here with Josephina. She works between 10 and 30 hours a week at a pizzeria. She earns $6.50 an hour, but can earn tips. So our first task is to write a system of inequalities to represent the dollars D she could earn for working H hours a week. So first step in any word problem is to define our variables. In this case, they define them for us. We have D dollars and we have H weeks. We're supposed to take a look at this problem, the first sentence. She works between 10 and 30 hours per week and create an inequality from that. Then we need to look at the second sentence. She earns $6.50 an hour and create a second inequality from that. And then what are we asked to do? We are asked to graph the system, and then we're going to go ahead and take a look at problem C. Okay. So let's go ahead and put this away and take a look at our document here. Alright, so we have H and we have D. And so the first sentence tells us that she works between 10 and 30 hours a week. So between 10 and 30 means including 10 and including 30. All right. So let's go ahead and write an inequality. If we have H hours, we could say hours per week is somewhere between 10. So we say 10 is less than or equal to H, and that's less than or equal to 30. So H is between 10 and 30 inclusive. Now we need to create a second inequality with the information that she earns $6.50 per week. Per hour, right? So D, the amount that she earns, is equal to $6.50 times the amount of hours she works times H, right? D is equal to 6.5 times H. However, she can also earn tips, which means that she can also earn more than $6.50 per hour. So we're going to say D is greater than or equal to 6.5H, and that's it. Right? So she can earn 6.5H, 6.5 times the number of hours, but she could also earn more than that. So we have our two inequalities. But this inequality here is not really one inequality. It is two inequalities. It is 10 is less than or equal to H, and H is less than or equal to 30. Right? So let's go ahead and write those two inequalities. 10 is less than or equal to H, and H is less than or equal to 30. So we actually have three inequalities. 1, 2, and 3. And we need to go ahead and graph them on a separate sheet of graph paper. Let's go ahead and grab that. We'll create a graph here, where again we shouldn't have negative hours, right? Or a negative amount of money. So our our x-axis is going to be our H, and our y-axis is going to be our D, the amount of money. So how can we graph this? Well, let's go and graph the first equation, or inequality. And we could do that by saying H is greater than or equal to 10, right? Let's go ahead and write that. Or H is greater than or equal to 10. All right. So what do? On the H-axis, we go to 10. So let's say 10 is right here. 10. 3, 4 is 20. 1, 2, 3, 4. This is 30. All right. So H is equal to 10, and what are we going to do? We're going to draw a vertical line on it, and it is going to be a solid line because our inequality is greater than or equal to 10, right? And so now the question is what side do we shade, the left side or the right side? And we'll use this here as our test point, our 0, 0 as our test point. So what is our test point going to be? It's going to be test point is going to be 0, 0. And we will insert our H into the inequality, and we'll get 0 is greater than or equal to 10. Is that true? 0 is greater than or equal to 10. No, it is false. So since it's false, in our graph, we shade in the side that does not include the test point. Does not include the test point, which means we do this side here. Right? Now we're going to go ahead and graph our second inequality. H is less than or equal to 30. So we're here on 30. We're going to draw a horizontal line, and it is going to be a solid line because it is less than or equal to 30. And now we're going to use 0, 0 as our test point again because 0, 0 is not on the line. Right? So we're going to go ahead and put in 0 is less than or equal to 30. And we check, is it true, right? 0 is less than or equal to 30. Yes, that is true. So since it's true, we're going to shade the side that includes the test point. We're going to shade this side. So far, what is our solution? It's the overlap. It's right here in the middle between 10 and 30. Right? However, we still have a third inequality in the system. We have inequality 1, inequality 2, and inequality 3. Right? So let's go ahead and graph inequality 3. For inequality 3, we need to start by putting it into... We need to start by putting the inequality into slope-intercept form. And if you notice, it already is in slope-intercept form because our d is our y and our h is our x. So we have y is greater than or equal to 6.5x. All right. So now that it's in slope-intercept form, what do we do next? We identify our m and our b. And our m in this case is going to be 6.5. Our b is going to be 0. There is no b. There is no y-intercept. Right? So what we can do is go ahead and graph that. Let's go back to our graph starting with our b, and we're going to put our first point at 0. Then our slope is 6.5 over 1. 6.5 over 1. Okay, so let's go 1, 2, 3, 4, 5, 6. Well, let's shorten up our scale. Let's make 6.5 right here. Let's make this 10. And this here 20. And this here 30. And 40. So, oh no, I messed up. So here would be 10. Yikes. Here, 1, 2 would be 20. 1, 2 would be 30. 1, 2 would be 40. And up here would be 50. Right. Okay, so 6.5 would be right about here, and we're going over 1 would put us right about here. 6.5 would take us, plus 6.5 would take us to 13, right about here, and we move over 1. That would put us here. Up 6.5 and over 1 would put us here, and then we have our line. Let's get our straight edge and draw our line. This here is not exactly accurate, so bear with me. Okay, and we are drawing a solid line because it is less than or equal to. Now the question is which side of the inequality do we shade in? Right? Well, we can't use the test point 0, 0 because 0, 0 is on the line. All right? So let's use the next best. Let's do 1, 0. Let's use this test point here. All right? So if our test point is going to be 1, 0, and we plug into our inequality there, we get 0 is greater than or equal to 6.5 times 1, or 0 is greater than or equal to 6.5. Right. Is this a true statement or is it a false statement? False. 0 is not greater than 6.5. So since that's false, we're going to go to our graph and we're going to shade the area that's not include the test point. So we're going to shade this side over here. Now, what is our solution? What is our solution? The solution is where all three graphs' shaded areas overlap. Right here on the graph does not overlap with this shaded area here. Right? Neither does this overlap. This does not overlap. It overlaps with this shaded area and that shaded area, but it does not overlap with this shaded area. Right? So where do all three of the graphs have overlapping shaded area? Because that is our solution. It's right here. All right. And if I drew my graph a little bit bigger, we would have more shaded area. But that's our solution. So now we have the question here. If Josephina received $11.50 in tips and earned a total of $180 for the week, how many hours did she work? Right? Well, we can go ahead and drop it into our third inequality. What is our third inequality? D is greater than or equal to 6.5 times H. But we also need to add our tips, right? Plus our tips. Okay, so if we go ahead and insert in or substitute in 17.5 for our tips, and we also insert in 180 for D, the money earned, we can figure out how many hours she worked. So let's go ahead and do that. So we have the inequality 180 is greater than or equal to 6.5 H plus 1750. Let's go ahead and solve for H by subtracting 17.5 from both sides. And we will get 162.5. Is greater than or equal to 6.5 H. Now we're going to divide by the coefficient 6.5. And we will get our answer as 25. So H is less than or equal to 25. All right. So how many hours did she work? Well, she worked 25 hours. There we go.